Refraction is the effect of a wave changing direction as it travels from one medium to another. This act of a wave travelling from one medium to another is called transmission, with refraction being something that happens when transmission is at an angle. For example, we could have two media, of air and glass. These are both media that visible light waves can travel through. So let's suppose we have a ray approaching the glass from the air like so. When we say ray, we mean a thin beam of light that travels in a single direction. At the boundary between air and glass, light will transmit from one medium to the other like so. But notice that the ray has now changed direction. This is refraction. We would see something similar if the ray exited the glass back into the air. Let's have a look at another common example of the refraction of light. The refraction of visible light can make objects appear to be in a different location than they actually are. Remember that we see objects because the visible light reflecting off them reaches our eyes, which then deduce where the light originated from. Here's an example of us trying to look at a coin at the bottom of a tub of water. To do this, we need light rays from the coin to reach our eyes. Let's suppose the light is reflecting from the coin in this direction. But at this point, it's reached a boundary between the water and the air, so transmission will occur. But this is happening at an angle, so there must also be refraction. The light will change direction at the water's surface and continue like so to our eye. But why does this affect how we see the coin? Well, when our brains determine where an object is, it assumes light only travels in a single direction. It doesn't consider effects like refraction or reflection. In this case, our brain follows the line back in a straight line into the tub, so the coin appears to be here. You can easily try this at home by putting a coin in a cup of water and looking into it from an angle. But is all light reflected the same way? Different wavelengths of electromagnetic waves will actually refract at different angles. The easiest way of demonstrating this is to refract light with a glass prism. To start with, we send white light into the prism. Remember that we get white light when we overlap electromagnetic waves with all the possible frequencies and wavelengths of the visible spectrum. Inside the prism, we see that the waves split apart into different colours. Remember that the colour of visible light is determined by its frequency, which also affects its wavelength. You don't need to know why, but waves of different wavelengths travel at different speeds in the prism, which affects the angles they refract at. So each wavelength from the white light is travelling in a different direction. Normally, these different rays are brought together when going back into the air, but the prism is shaped so that they are instead split further. So we can clearly see how the colours have been split up from the refraction. But is it only light waves that can refract? Well, refraction can also be observed in other types of waves. For example, we can demonstrate refraction visually in a ripple tank, where we send water waves across the surface of some water and observe their peaks. Here we've split our tank in two. On the left we have deep water, and on the right shallow water. This angled line where we've changed from deep to shallow water is a boundary that water waves will have to transmit across. We disturb the water from the left, creating ripples in the tank. We can use lines to represent the peaks of these waves as they move to the right. As we can see, they're all vertical and perpendicular to the direction they're travelling. But after passing the boundary, they're now at a slight angle. This means the waves will now be travelling in this direction. This is because the waves have refracted at the boundary, which has caused them to change direction. You should also be confident explaining how this happens for other mechanical waves, like seismic waves and sound waves. The principle is the same for any type of wave, as long as they are able to transmit through a boundary.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!